Hello everyone, welcome to my YouTube channel Shilpa Data Insights. Hi, good morning everyone. So let's begin with the day 5 workshop for Databricks. So we have covered a lot of topics already in the previous days. So the last topic that we covered was the Unity catalog and the role-based access control along with the secret scope. So in today's session, we will be discussing about the Delta Live Tables. So, in today's agenda, it will be related to the Medallion architecture. What is actually a Medallion architecture? Why exactly the Medallion architecture is needed? What is the ETL process for it? How complex it is to manage the ETL process? And what is a Delta Life table? What are the core components of the Delta Life table? How you can create your Delta Life table notebooks, and then we will discuss on what is a delta pipeline and how you can create that delta pipeline and monitor the delta pipeline at the same time. And then we will be creating a job, and we will also see how we can go ahead and schedule a particular job. So let's start with the first topic that we have for the day, that is the Medallion architecture. So Medallion architecture is actually a data design pattern which is used to logically organize your data into your lake house. It has a goal of incrementally processing the data, and it will do a data quality check as the data will flow from each layer of the architecture, from bronze to silver to gold layer. So basically, in the Medallion architecture, there. Okay, so basically they are.
I would request participants to please be on mute if you're not speaking.
So basically, there are three layers in the Medallion architecture. So the first one is the bronze, and the second is the silver, and the third is the gold. So we will discuss about each layer in the detail in the next coming slides. So first, understand what benefits that the Medallion architecture actually gives us. So the first thing is the ACID property, which is the most important property that the data will need. So that is guaranteed over the Medallion architecture as the data is progressed through the layers. Then it also enables you with the schema enforcement and the schema evolution. So you don't have to worry about that. Then it comes with a BI compatibility, and the storage and the compute that you have, it is decoupled. It's actually not coupled, so it is actually beneficial while actually storing your data and doing some computation on the top of it. It also allows you to work with different data types like your CSV, Avro, Parquet, ORCs, and all. And it can also help you with the versatile workloads, means you can either create your Delta Live tables or you can create your normal workloads or over the compute cluster or your serverless clusters. It also helps you with the real time processing along with your batch processing. So let's first understand what is the architecture that we have for our medallion. So the layers, there are three layers as we were discussing. One is called the bronze, second is the silver, and the third is the gold. As the data is coming from the source layer, the data could be a batch, it could be a streaming data set. So those are actually a raw data that you are getting from different sources. So those data is saved in a one layer which is called your bronze layer. So all your raw data is saved in your bronze layer. That is also called as landing zone for raw data. In that landing zone, the schema is not required, it is stored as it is coming from the source. So as you are progressing the data and doing some cleaning operation, those data are stored in the silver layer. So in the silver layer, you are actually defining the structure of your data, you are creating your details and enforcing the schema, or you are evolving the schema as needed. Along with it, you can also filter the data whatever is being required. If there's any bad data, you can actually clean it up. If there's any null data, you can clean it up and you can store it in your silver layer. Once the filtered and clean data is there, then you can go ahead and do some more processing in order to get your business level aggregates, and your cleaned along with the business level aggregates is stored in your gold layer. Once the data is available in the gold layer with all your groupings, all your operations, then it is actually given to the BI team or the ML team or any team who needs the data according to their business. And on the top of that, the team creates their dashboard or do any kind of business operations, ML operations. So this seems to be a very easy ETL process that we have. And as you move the data from raw till the gold, the data quality check is being done as well, so that you get the good data to the business team who actually doing the predictions and all. This seems to be very simple, but in real time scenarios, as you have known, that this is not so simple as it is. There are multiple tables involved, and why exactly it comes is because of this. Once you have your raw data coming from different sources, then either you are doing any kind of a join operation, you are filtering out the data. And once you have done that, there are multiple tables that are created at the time of filtration, joining, and all those operations. So they, let's say the silver layer is having 20 tables, and those 20 tables are coming from, let's say, 5 tables from the raw layer. Why those 20 tables are coming is because of the operations that you have followed. And then from there you are actually again creating multiple tables, and those tables are dependent on your silver table. So the architecture is actually complex if you think about that. So it's not so simple that you have your raw and then you have your silver and then you have your gold. This depends on how the data modeling team has done the data modeling for your complete overall architecture. Okay, so now the regarding the complexity of ETL, if you are working in a project, you might have seen how difficult it is to handle the error and do a recovery, because it's quite a laborious process, because it has a lot of dependencies on different tables from source till the target table. So while the data is traveling, there could be multiple errors and it's very difficult to handle them. And the data quality that is also there, if in case it's poor because of the schema or some constraint, then you have to improve the data quality process. So that is also again a second task, a laborious thing that you need to do. When you are actually tracking down the data quality or error handling, you need to know the dependencies of the tables. So you need to track down the data lineage. Again, that is also a second effort that you need to do in order to track down the data lineage. And when the data is flowing, then you need to know which data is coming from batch or it is coming from a streaming level. And that actually is a very tedious job in order to do that, right? So in order to simplify everything, what Delta Live Table is doing is you just create your table of Delta Live Table on the top of your Delta Lake, and the rest, let's say the data lineage, is being taken care by the Delta Life table itself. So the data lineage means the data management, what is your upstream, what is your downstream, which data should be updated after which table. Those things are taken care by Delta Life table. If you have your data and you want to do a backfilling of your data because of some data discrepancy, that is also handled by Delta Life table. If the pipeline fail, for example, then you can also go ahead and do a checkpoint and retry policy. Along with that, it also provides you the quality check. Let's say there are some bad data coming up, and you will not want that bad data to go to your downstream data. So that quality check is also done by Delta Life table. Then comes with the governance. So you don't want the sensitive data to be displayed to people, so that is also being taken care on the top of the Delta Lake by Delta Live table. And then we have the data discovery. So data discovery is there so that the right people can find that right data and then they can use it for their own business purpose. Then you have the version control that multiple developers can work on it at the same time, and the deployment infrastructure. As the data is scaling, then you have to deploy the infrastructure, scale your infrastructure as well. So all these things are actually very time consuming. So time to maintain these tool is actually dominating, as it is complex, right? And we are actually not focusing on getting the value of data. So the purpose of Delta Live Table will be actually to create the Delta Live tables and leave the rest of the infrastructure management to Databricks. So the dependency management, full refresh, checkpointing, Unity catalog, the workflows, all these things are being taken care by Databricks with the help of the Delta Live tables. So we will see all these features, how exactly it's been done in the practical as well, so that we have a better clarity how exactly the Delta Life table is actually doing these processes in the backend. So first of all, let's understand what is a Delta Life table after having that Medallion architecture that we discussed. Delta Life table is nothing but it's an ETL framework. It is a declarative ETL framework which will help you in building your pipeline. It will define the transformations that you can perform on your data, and the DLT pipeline will automatically manage your orchestration, your cluster management, your monitoring, and the data quality checks. It will also help you with the error handling. So, all these things are being taken care by Delta Life Tables itself, so that you can just concentrate on what type of data you are getting and get the insights from the data itself.
Shilpa, just to interrupt here, like, is it the same, the Delta Live tables which we have seen in the last call, like the Delta table? Is it the different one, Delta Live tables?
So this is
They're the
a
same, right?
different, no, it's a different one. Delta tables are on the top of Delta Lake. Delta Live tables has the feature in which you go ahead and create your pipeline, and all these features that I have discussed right now are actually taken care by Databricks. But in Delta table, you have to do these things by your own. You have to make sure your cluster management is done, your orchestration, your data quality, all these things you have to do it manually. But here, most of the things are being taken care by Databricks with the help of a configuration that you are just setting up.
Okay, so it works basically on based on this configuration. So the and you talked about this Medallion architecture where this silver, bronze, and those layers are there. So how the Unity catalog is differ from that? Like that is also because Unity catalog also we use for the data lineage, right? Or the metadata management. So how this Medallion architecture is different from there?
I'll show you. So basically, this DLT tables, you will be able to see the lineage in the pipeline. Whenever you are
Okay,
creating a pipeline, then only once it is created you will be able to see. In Unity catalog, you are writing your codes for Delta tables, and by default it's creating the lineage out of it.
okay, by default it is creating. And here in this like Delta Live tables, we are able to see that like how this lineage is working in
Yes,
this
so
live
you
tables.
create your notebook in which you mention out the things. Out of that, it creates your pipeline. I will show you how exactly the pipeline is created. First of all, you create your notebook, and once the notebooks are created, by default it creates the lineage in your pipeline format. So I will come
Okay,
to
okay,
that and show
yeah,
you. If in
yeah,
case any
yeah.
other
Okay,
thing is there, we will discuss that in the end as well.
yeah, sure.
Okay, so the core components that we will be having in the Delta Life table is, first is the streaming table, and the second is the materialized view. In the streaming table, it's a Delta table itself with the streaming rights into it. So it's a Delta Life table where you can do a streaming write, and this is used for any kind of streaming ingestion, and if you want any kind of low latency transformation, and if you want to also use these tables at huge scale. And in the materialized view, as the materialized view is the result of a query that is actually stored in the delta table, and that is used for transforming the data, or you can build the aggregate tables on the top of it, and you can speeding the BI queries and reports. If the BI queries and reports are slow, you can go ahead and create the materialized view on the top of it. So it's actually very beneficial to create a materialized view in the gold layer so that the BI queries or reports run on those views. So let's first now deep dive into Delta Live Tables. So when we are creating a Delta Live Tables, we have to give the keyword as live table. If it's a streaming live table, you can give the keyword as streaming live table. So that will depict that it's a Delta Live Table. You can also refresh the query to process your latest data with the refresh command, and to create a live table in Python in the Databricks, you can use your decorator, that is your at dlt.table. And while the data is actually being flows from raw to the gold layer, you want to do the data quality check. For that, we have the expectations. Those are basically to test your data quality, and the result of the expectations are Boolean expression. It could be a true or false. So for expectations, whether it will be, it can actually track the bad records, it can drop your records, or it can completely abort the processing for a single bad record. So there are some decorators that are available for data quality expectation. The first one is expect. If you are expecting the data to be there, but it's a bad record, you just mention expect, or you can mention expect or fail to drop it, or you can expect or fail to abort it, or you can expect or drop to actually drop the records. So now let's see the Delta pipeline. So for creating a Delta pipeline, first of all, you need to create a notebook. It could be a SQL or a Python notebook. You can also have an environment configuration file to accelerate your development, and the DLT will infer the dependencies between the table from the notebook itself that you have created. You can also manage the Delta pipeline with the help of scheduling the pipeline. You can monitor the pipeline as well. You can auto scale your clusters, and you can create the complete workflow from the Delta pipeline. So the next thing that we have is creating a job. This job is not referring to the Delta pipeline, but it's just a normal job. Inside this job also you can lineage your Delta pipeline basically. So in this workflow icon, you will see there's a task. You can create multiple tasks. You can provide your task name, what type of task you want to create. You want to actually read the notebook, you want to read the SQL editor, or you want to read go through the DLT pipeline. You can also mention what is your path of it, what is the compute cluster that you want, and if in case there's any dependent libraries that you have not put inside your notebook or inside the cluster level, you can mention that dependent libraries. And you can put your parameters. You can parameterize the notebook as well. While it's running, it will take the runtime parameters. It will also mention what is your job ID cluster and what is your run as. You can also actually go ahead and schedule your pipeline here and mention your job parameters or edit it. And you can queue the pipeline as well. Let's say you want to go ahead and run two pipelines, the same pipeline at the same time. You can queue it, and you can maximize it with the concurrent runs. So in order to schedule the pipeline, you can mention the add trigger here on the right side. And once you click on add trigger, it will ask you whether you want to trigger the pipeline on a daily basis, or on a weekly basis, or an hourly basis. You can go ahead and mention that. So let me go back to my Databricks. So in this Databricks, you see we have this workflows on the left side. In this workflow, we have the jobs, we have the job runs and the Delta Live table. So in order to first create the job, you have to click on this create job, and inside this job it will ask you multiple options. The first one is your task name, that is, let's say you can give any task name to it, so it will be replicated here. Then you have your notebook as the type. You can use any type here. You can also go ahead and use your Delta Live table pipeline here, or you can use any Python script or your jar or dbt. All these options are being available. And you can mention the source, what is exactly the source. If in case it's the notebook, it could be either your repos or your workspace that you can select. Then you can also mention your cluster. It could be a job cluster or it could be a all-purpose compute cluster. Then the dependent libraries you can mention, and the parameters. You can use your UI to mention your parameter, or you can put your JSON here. And the notifications with the retries. Let's say if the pipeline is failing, you can retry it with some attempts that you want. Let's say you want the pipeline to run twice, then you can just mention it twice. Even if it fails, it will try it one more time. And the duration threshold as well. So once you create the task, it will be shown in your task itself, and you can see all your runs in your runs here. So let me go back to your jobs, and in the jobs run you will see the run as here, what is the date and what is the run status. It will show you all the start time, which job it was running, and what is the launch, whether it's manual, by file or by scheduler, and whether the status is completed or it's failed. If in case there's any error code, it's going to display it here itself. Now let's come to the Delta Live tables. If you go to Delta Live tables, there will be option to create your pipeline. So if you click on this create pipeline, it's going to show this particular page from where you can create your pipeline. Let me Okay, so you have to first give the pipeline name here. What is the pipeline? And here we have the pipeline mode. If you want the cluster to stop as soon as the Delta Live pipeline has been completed, you can mention it triggered. If you want it as a continuous, you can mention this as a continuous method. Then you can mention the path of the path of the notebook that you want to use to create the pipeline, and the target schema. The target schema right now, we have the capability of Hive Metastore. Basically, Unity Catalog is in preview, so by default, I have created it in Hive Metastore, and I want to create a schema called Shilpa underscore DLT. Now, if in case there's any cluster policy, you can go ahead and mention your cluster policy and the cluster mode. If you are enabling the auto scaling, it will allow you to auto scale it from minimum workers 1 to minimum workers 5 right now. If you want, you can change this configuration as well. And there are some more. Let's say what worker type you want, any specific instance type you want, you can go ahead and select it from the drop down list, like general purpose or memory efficient cluster. Then you can select that. So once you have selected these settings in your Delta Live table pipeline and save it, then you go back to your notebook. First, you need to actually create the notebook that we have referenced here. That is the sample DLT pipeline notebook. So in order to create this notebook, you just simply have to go to your notebook in the same manner, and I will show you what exactly it displays. Okay, so this is my sample DLT pipeline notebook. In this notebook, I am first creating few tables. So let me first show you how exactly it will look like in the lineage, and then we will come to this and discuss on this. So this is my pipeline that I've created. This I did not create it. I created the notebook definition, and the Delta Live table has already created these lineage to understand which particular table to run first and what table to run later. So the first two table that I will be declaring is my streaming table. This is my raw layer, that is my bronze layer. The third table that I will be declaring will be in my silver layer, and the next two tables are in my gold layer. So these two tables I have created it as a materialized view. So let's go back and see how we can create the live tables. So in order to create the streaming live table, we have to use the keyword as streaming live and table and the table name. And there could be any table properties that you want, and you want to select the data from a file, let's say, because it's a streaming live table. I'm using a cloud files option. This cloud files option is an autoloader option. So we will discuss this autoloader in the last session. So using the autoloader cloud files option only, we are saving the data into the live table customer. So I've mentioned what format of the file we are actually reading. The format of the file is the CSV customer. So once we have loaded the data into my customer table, then I will be loading the data into my sales order raw table in the same manner as we are loading in the customer. So I'm mentioning this file is a JSON file. So I will be loading this JSON file into my this particular table using the streaming live. And one thing to note, I will not be able to run this notebook from the run command in this particular interactive cell. I can only run this notebook with the help of my DLT pipeline that I created. So I will show you that. Now let's say there is the second layer that we have, the silver layer. In this silver layer, this is the sales order clean, in which I don't want any order number which is null. If there's any order number which is null, I'm putting a constraint called valid order number. And if it does not expect any null value, so those orders will be actually dropped. So therefore I am mentioning on violation of this particular constraint, I will be dropping those rows. And I'm partitioning the table by order date, and I'm doing some transformation on the top of the previous live table, the raw table and the customer table that we had, and then storing the data into my clean table. While reading the data from the raw table, that is my raw and customer, as it's a Delta Live table, you have to mention the keyword as live dot. Once you mention the keyword as live dot, then you can go ahead and store the data into your this table after reading these two tables. There's another table that I will be creating here, that is my materialized view itself. And in this view, I am again using the clean table, the live table, and I'm doing some transformations and storing it into my gold layer. There's one more table, that is my sales order Chicago table, in which I'm doing some more transformations, doing some aggregations, and saving it into my sales order Chicago. So as soon as I create this particular pipeline, as soon as I save this option, then this particular pipeline is created without any operation on the top of it. If you want to go ahead and run this pipeline, then you need to click on the start button. It will first go ahead and get some kind of resources. It will wait for the resources. Once the resources are ready, it will start initializing, and then it will set up the table, the graph that we just saw, right? Once the table is set up, then the graph is automatically created, and then it will also show you the lineage and the logs, sorry, the logs of it, whether the table has been successfully loaded. If there is any error, any violation of the constraint, it will show you that result. This is going to take some time basically to load, get the resources, around 5-7 minutes. Once this data is loaded, you will be able to see the same graph that I was showing you before. And you can also go ahead and schedule this particular delta live table from the right top side. And if you go to the settings option, the same page will appear in which you can go ahead and modify your pipeline details from here. Let's say you don't want the target schema as Shilpa underscore DLT, you can change this target schema. So if you would have noticed that I have not mentioned any schema here, so what it will do is it will create this particular table inside my schema that I have defined into my DLT pipeline. So it will take that schema and load the table in that particular schema itself. If I will go ahead and go to my catalog explorer, here in the high meta store, it has created this Shilpa underscore DLT. In this, there will be the tables that I will be creating or I have already created using my DLT pipeline. So, so if you will see, the first table that we created is my customer sales order is my gold layer, sales order LA is my gold layer. This is my this is my silver layer, and this is my bronze layer. So this is the same Unity catalog explorer that we discovered before, but this is not my Unity catalog. This is my high meta store in which I'm actually checking. And if you want to go ahead and check the details of it, where exactly this particular location is there, it is in my hive warehouse itself. And then you can also see the permissions of what exactly permission is being granted for this particular table. So actually, this will take some time to go ahead and take your resources. So if you will see, the user action is there. It has created the update. Update is in progress, means it's waiting for the resources here. So once the resource is ready, then it will start initializing and it will actually run the complete workflow in it. So here, if you have seen, I don't have to mention basically the cluster. If you want, you can mention what worker types you need, but if you are not mentioning the worker types, it's actually going to by default select the worker types that is currently available. You can definitely do an auto scaling operation as well, and you also have a refresh option on the top here, where you can go ahead and refresh your complete all the tables or selected tables. I think let this particular thing run, then I can show you the graph of it. Meanwhile, if we have any questions, we can take it up.
So Shilpa, most of the streaming use cases only we consider in this data like tables, or the batch processing also we consider doing it.
You can also consider using your batch processing. It's not necessary only the streaming tables you want
But
to
any
use.
extra benefits compared to the normal tables in this delta like tables for the batch processing.
So again, those things I was discussing, you can have your lineage, right? You don't have to actually get your lineage out of it. And then this is like a declarative process, right? You don't have to tell how exactly you have to do. Let's say you are mentioning the constraint, yeah, you are mentioning the order number need not to be null and you are just dropping it up. So these are the things like the batch streaming also provide. You just have to go ahead and take care whether there is any error, you have to manually go ahead and fix it. So in this, it will just go ahead and show you how much data quality check has been done, how much data has been failed, right? So these are some functionalities that batch, even if you are using batch, it is actually helpful.
Yeah, so like most of the automation things is already taken care by these DLTs, right? The
Correct,
data lineage
yeah.
and all those things.
Right. So that is that you don't have to take a headache of actually, you have to do some further thing, right? So that's why. So if I show you just to show in that case for everyone, so this has started, right? So in this customer, if you will go to the schema, it will show you the schema. So you really don't have to go ahead and see, like, describe your table and it will show you the schema, right? So you have the pipeline, it's running at that time only you can see the schema out of this particular thing. And you have not even mentioned the schema in your uh, notebook. It has automatically picked the schema of the uh, file and it has shown you. If you want to edit it, definitely, like most of them are string, if you will see, you have to edit it as per your requirement, but it will show you the schema which is handy. And then in the flows it will show you what type of flow it is, whether it's incremental or not. So let me show you the silver layer here. In the silver layer, we go to the schema. Again, the schema is there, but there's a data quality check as well. So you don't have to do much effort into it. Okay, so in this data quality check, you can see how much data is written and how much data is actually dropped. Okay, so if you will see, the failed records is 0, so there is no record that has been dropped. So all the order number that we have mentioned in the constraint is not null, so it has not dropped any row. So this is a data quality check that it will do, and it will show you in a visual format so that you can know, and it will actually give you the details of it. Then you can definitely check where exactly the data is breaking up. Similarly, in the materialized view, it will show you if in case some data is written or not, and how much data is written, what is the flow of that, from where exactly the data is flowing, and the flow type is completed or not. So these are some benefits that you will be getting while actually doing it. And you can also do a refresh. You don't have to do a refresh command. You can select the tables that you want to refresh. Let's say one upstream table only you want to refresh your downstream table, so you can select those tables to refresh it. Thank you so much for watching, and I wish you have a good day.